Section 215.3 of the National Electrical Code, or NEC, serves as the foundational basis for determining the appropriate size of the overcurrent protective device, or OCPD, in situations involving non-continuous loads. This section's broad applicability encompasses all types of non-continuous loads, thereby including motors within its scope. Conversely, Section 430.633 possesses a more limited scope, specifically addressing only motor-related applications. Consequently, in scenarios where only non-continuous loads are present, and these loads include motors, relying on Section 215.3 is sufficient for accurately calculating the required OCPD size. However, a crucial nuance arises when the non-continuous load is comprised of a combination of both motor and non-motor loads. In such instances, a dual approach is necessary to ensure accurate OCPD sizing. Firstly, Section 215.3 should be employed to calculate the OCPD requirements for the non-motor loads present in the circuit. Secondly, Section 430.633 should be utilized to independently determine the OCPD requirements specifically for the motor loads. Upon obtaining these two distinct OCPD values, a comparative analysis is performed. The larger of the two calculated OCPD values is then selected as the appropriate OCPD for the entire load, encompassing both motor and non-motor components. This approach guarantees that the OCPD is adequately sized to protect all elements of the circuit, accounting for the distinct characteristics and requirements of both motor and non-motor loads. To elaborate further on Section 215.3, it generally deals with feeder overcurrent protection for continuous and non-continuous loads. It provides guidelines on how to size the overcurrent protection device based on the ampacity of the conductors and the characteristics of the loads being served. The section emphasizes the importance of selecting an OCPD that is capable of carrying the continuous load without nuisance tripping, while also providing adequate protection against overloads and short circuits. It directs the user to other articles within the NEC for specific requirements related to different types of loads, such as motors, air conditioning equipment, and electric space heating. Section 215.3 covers continuous and non-continuous loads. The rating of the overcurrent device shall not be less than the non-continuous load plus 125% of the continuous load. Section 215.3b covers feeder taps and is not applicable in this case. Section 215.3c covers next higher overcurrent protective device rating. Where the ampacity of the conductors does not correspond with the standard ampere rating of a fuse or a circuit breaker, the next higher standard device rating shall be permitted only where this rating does not exceed 800 amps and the conductors are not part of a multi-outlet branch circuit supplying receptacles for cord and plug connected portable loads. Section 430.63 addresses overload protection for motors and motor circuits. Specifically, Section 430.633 likely refers to a specific provision within that section related to the calculation of the OCPD for motor circuits under certain conditions. It may address situations where the motor is part of a larger assembly or system, or where there are specific considerations related to the motor's duty cycle or application. To fully understand the intent and application of Section 430.633, it is necessary to consult the actual text of the NEC. When dealing with electrical calculations, it is critical to be precise and accurate. The NEC provides detailed instructions and formulas for calculating conductor ampacity, OCPD ratings, and other important parameters. It is essential to follow these guidelines carefully to ensure the safety and reliability of electrical installations. It is also important to understand the different types of loads that may be present in an electrical system, such as continuous loads, non-continuous loads, and motor loads. Each type of load has its own unique characteristics and requirements, which must be taken into account when performing electrical calculations. For example, continuous loads are expected to operate for 3 hours or more at a time, while non-continuous loads are not. Motor loads can have high inrush currents during startup, which must be considered when sizing the OCPD. When performing electrical calculations, it is helpful to use a systematic approach. This may involve creating a load schedule to identify all of the loads in the system, calculating the ampacity of the conductors, selecting the appropriate OCPD, and verifying that the installation complies with all applicable requirements of the NEC. It is also important to keep accurate records of all calculations and design decisions. These records can be helpful for troubleshooting problems and for future reference. The NEC is a complex and comprehensive document, and it is essential to stay up to date on the latest changes and revisions. The NEC is typically updated every 3 years, and each new edition may contain significant changes that could affect electrical installations. It is also important to consult with qualified electrical professionals when performing electrical calculations or designing electrical systems. These professionals have the knowledge and experience necessary to ensure that the installation is safe, reliable, and compliant with all applicable codes and standards. Sizing an OCPT correctly is paramount for electrical safety. An undersized OCPT will trip unnecessarily, interrupting power and potentially damaging equipment. Conversely, an oversized OCPT will fail to protect the circuit from overloads and short circuits, leading to overheating, fires, and potentially hazardous conditions. Therefore, understanding the NEC guidelines and applying them accurately is crucial for ensuring the safety and reliability of electrical systems. In summary, Section 215.3 provides the general guidelines for OCPT sizing based on continuous and non-continuous loads, while Section 430.63 offers specific guidance for motor loads. When dealing with a combination of both types of loads, a careful and considered approach is required to ensure that the OCPT is adequately sized to protect the entire circuit. Relying on the larger of the two calculated OCPT values, derived from both sections, ensures comprehensive protection against overloads and short circuits, safeguarding both equipment and personnel. It's also important to consider the specific application and any relevant exceptions or modifications outlined in the NEC. Consulting with a qualified electrical professional is always recommended, especially when dealing with complex electrical systems or when unsure about the correct application of the NEC. Remember to always prioritize safety and accuracy when working with electricity. Always to energize circuits before working on them and use appropriate personal protective equipment, or PPE. If unsure about any aspect of an electrical installation, consult with a qualified electrician. Electrical safety is everyone's responsibility. Always follow the NEC guidelines and best practices to ensure a safe and reliable electrical system. It's also worth noting that some local jurisdictions may have amendments or additions to the NEC. It is important to check with the local authorities to ensure that the electrical installation complies with all applicable requirements. Proper documentation is another important aspect of electrical work. Maintain accurate records of all calculations, design decisions, and inspections. This documentation can be helpful for troubleshooting problems and for future reference. It is also important to educate others about electrical safety. Share your knowledge with colleagues, family members, and friends. Promote awareness of the hazards of electricity and encourage safe practices. Electrical safety is a continuous effort. By staying informed, following best practices, and educating others, we can all contribute to a safer electrical environment. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always treat electricity with respect and follow all safety precautions. When sizing OCPTs, one should consider directing factors for ambient temperature, conductor bonding, and other conditions that might affect conductor ampacity. These directing factors are specified in the NEC and must be applied correctly to ensure that the conductors are adequately protected. Furthermore, the type of OCPT used can also affect the overall protection of the circuit. Fuses and circuit breakers have different characteristics and response times, and the selection of the appropriate OCPT type should be based on the specific application and the characteristics of the load being served. For example, fuses are generally better at clearing high fault currents, while circuit breakers offer the convenience of being resettable. When working with motor circuits, it is also important to consider the motor's starting current. Motors can draw several times their full load current during startup, which can cause nuisance tripping of the OCPT if it is not properly sized. The NEC provides specific guidelines for sizing OCPTs for motor circuits to account for the motor's starting current. These guidelines typically involve using a larger OCP than would be required for a non-motor load with the same full load current. In addition to overload and short-circuit protection, it is also important to provide ground fault protection for electrical systems. Ground fault protection is designed to detect and interrupt ground faults, which can be a significant safety hazard. The NEC requires ground fault protection for certain types of electrical systems, such as those serving commercial and industrial facilities. Ground fault protection can be provided by ground fault circuit interrupters, or GFCIs, or by ground fault protective devices, or GFPDs. GFCIs are typically used to protect individual circuits, while GFPDs are used to protect entire electrical systems. When selecting ground fault protection, it is important to consider the sensitivity and response time of the device. The device should be sensitive enough to detect low-level ground faults, but it should also be able to withstand transient voltage surges without nuisance tripping. The response time of the device should be fast enough to interrupt the fault current before it can cause damage or injury. Another important aspect of electrical safety is proper grounding. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the OCP and clear the fault. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metallic enclosures. Proper grounding is essential for ensuring the safety of electrical systems and for preventing electrical shock hazards. In addition to the NEC, there may be other applicable codes and standards that must be followed. For example, the National Fire Protection Association, or NFPA, publishes a number of standards related to electrical safety, such as NFPA 70E, Standard for Electrical Safety in the Workplace. These standards provide guidance on how to protect workers from electrical hazards. It is important to be familiar with all applicable codes and standards and to follow them carefully when working with electricity. Finally, it is important to remember that electrical work is inherently dangerous. Even with proper training and precautions, there is always a risk of injury or death. Therefore, it is essential to take all necessary safety precautions and to work carefully and deliberately. If you are not comfortable performing a particular task, it is best to seek assistance from a qualified electrical professional. In summary, sizing OCPs correctly is a critical aspect of electrical safety. It is essential to understand the NEC guidelines, to apply them accurately, and to consider all relevant factors such as conductor ampacity, load characteristics, motor starting current, and ground fault protection. By following these guidelines and taking all necessary safety precautions, you can help to ensure the safety and reliability of electrical systems.